Hi folks, and welcome back. This week we're going to be talking about anthropogenic climate change and population engineering. In particular, we're going to be looking at whether governments have an obligation to, or whether it is permissible for governments to intervene to lower the fertility rate of human populations around the world in order to avert some of the worst consequences of anthropogenic climate change. I want to start with a little background on climate change, though we're not going to spend too much time on the science. If you are not convinced already, nothing I'm going to say here is going to convince you. It's simply meant to be a bit of a background so that we are all starting off on the same page. We'll then turn to the question of whether governments can permissibly intervene to lower human fertility rates. So let's start by looking at historical CO2 levels. Over the past million years or so, the level of CO2, or the concentration of CO2 in the Earth's atmosphere, has ranged between 172 and 300 parts per million. That's a vast period of the Earth's history where we were within that window. We first broke 300 parts per million around the time the Titanic sank in 1911. So about 109 years ago. And in March 2020, this past month, the concentration of CO2 in the Earth's atmosphere was 415.11 parts per million. And that's about 3 parts per million higher than it was just a year ago. So it continues to climb. What does this mean? Well, there's robust science that shows that global temperature and CO2 move in concert with one another. That CO2 is a greenhouse gas that traps energy from the sun shining down on us close to the Earth's surface. It doesn't allow that energy to escape. And that energy is trapped in the form of heat. This means that our oceans are warming. This means that our climate is changing, that storms are becoming more regular, more prevalent, that temperatures are rising across the globe. We'll talk a little bit more about consequences in a second, but what we can see is that over the course of the Earth's history, there is a strong correlation between carbon dioxide concentrations in the Earth's atmosphere and the Earth's temperature, which we measure from ice cores, where we can measure the concentrations of carbon dioxide in the Earth's atmosphere and the concentrations of different isotopes of oxygen that correlate with different temperature or with changes in the Earth's temperature. Looking back over the course of the Earth's history, we see that for much of our history, the temperature of the planet has been lower than it is now, lower than it was for much of the last few hundred years. There have been some warm phases throughout the Earth's history, but for the most part, it's been relatively, it's been lower relative to pre-industrial reference levels than it has been over the last 200 years or so. But, as you can see on this chart, over the last few hundred years, the Earth's temperature has been rather steadily increasing, and it is projected to continue increasing past the maximum increase in temperature over the last 784,000 years over the next 50 or so. And this is something we should be seriously concerned about. I want to take a second just to show you a graphic that I find rather telling in thinking about the Earth's temperature. So this is a cartoon, a few years old, from a website called XKCD, and I will post the link to this on Blackboard so you can take a look at it yourself. But the cartoon shows us the Earth's temperature over time, where 0 degrees Celsius falls right here in the middle. Not 0 degrees Celsius, where the average temperature from 1961 to 1990 is set right here in the middle, and we can see deviations warmer or colder than that average temperature as we scroll down. And you'll notice that here we are at about 18,000 BCE. The ice sheets start to melt. The global temperature starts rising just a little bit, very, very slowly, over thousands of years. And we see here humans settle in Syria at about 11,500 BCE. We're still pretty early going for human evolution, the evolution of modern humans. We haven't seen the onset of human civilization yet. As we continue growing, continue warming and scrolling, we're finally seeing the birth of human civilization, the development of first farming between 10,000 and 9,500 BCE. We see the saber-toothed cat goes extinct. Finally, we see temperatures reaching modern levels between 9,000 and 8,500 BCE, and we see human civilization taking off. We see cattle domesticated, we see cities forming, we see pretty much everything we associate with the development of human civilization within this 2-degree range of the average temperature from 1961 to 1990. We see a stabilization of the Earth's temperature over the course of which Minoan culture arises, Egyptian culture arises, Middle Eastern cultures arise, Greek culture arises, Eastern cultures arise, Jesus is born. All of this happening within this 2-degree window. And this 2-degree window has persisted until very recently. And in 2016, we see we're about to embark into new territory, into territory where human civilization has never before been. And this is something that should be really worrying to us. We seem to be leaving this nice little window within which all of human civilization has existed and embarking into new temperature territories where human civilization has never tried to carry on. So we'll see what happens. Here are some of the things that we can expect. This is based on the Intergovernmental Panel on Climate Change, the UN body, on their report from 2018, when they looked at the difference between 1.5 degrees warming of Celsius, or 1.5 degrees Celsius warming and 2 degrees Celsius warming. At 1.5 degrees of warming, once per century, the Arctic would be ice-free during the summer. At 2 degrees, it would happen once per decade. At 1.5 degrees Celsius warming, 14% of the world's population would be affected by extreme heat waves that are nearly unlivable. At 2 degrees Celsius, 37% of the world's population would be affected by such extreme heat waves. At 1.5 degrees Celsius, 350 million people would suffer from urban water scarcity. That is, cities that don't have access to water, to potable water for their populations. We saw this happening in South Africa just a few years ago, where cities were nearly out of water during a drought. At 2 degrees Celsius, 411 million people will suffer from urban water scarcity. At 1.5 degrees Celsius of warming, plant and animal life will be lost. About 6% of all insects on the planet, 8% of all plants, and 4% of all vertebrates will be gone. At 2 degrees Celsius, 18% of all insects on the planet, 16% of all plants, and 8% of all vertebrates will be gone. We're already living through a mass extinction. We're already seeing species of animals and plants and insects disappearing at rates at which they haven't for millennia. And that's only going to accelerate as the temperature rises. At 1.5 degrees Celsius, 80% of coral reefs are lost. At 2 degrees Celsius, they're essentially all lost. All life on coral reefs would be lost. Sea level rise, at 1.5 degrees Celsius, 31 to 69 million people will be exposed to flooding from sea level rise. At 2 degrees Celsius, we'd likely see an additional 10 centimeters of sea level rise, endangering 32 to 80 million people who would be exposed to flooding. We already see this even around here. Even in Old Town Alexandria, we see far more sunny day flooding than we have in the past as a result of sea level rise, because the Potomac is a tidal river. A couple of years ago, an article came out in the Intelligencer, the Daily Intelligencer, called The Uninhabitable Earth by David Wallace Wells, and he examined some of the worst case scenarios that would happen if climate change continues unabated. And things don't look good. He published a book a couple of years later on this same topic, and it's worth taking a look at if you're interested in reading about the direction the planet seems to be headed. But we're likely going to face famine. We're likely going to face economic collapse. We're going to see our supply chains, especially our food supplies, collapse. We're going to see parts of the earth become uninhabitable because they become simply too hot to live in. We're going to see other parts of the world that become nearly uninhabitable because of the frequency of storms and wildfires that will affect these places. And we're going to see massive political disruption wrought by immigration as people try to flee these uninhabitable parts of the earth. These places where famine becomes rife, where it simply is impossible to carry on meaningful human life. And countries that are better off and better equipped are likely to react to this immigration by closing their borders, by fighting wars to protect the land that they have that remains inhabitable. So the effects are likely to be felt very differently by different populations. So what do we need to do to avert these worst outcomes, if it's possible at all? Well, in the 2018 report, the IPCC said that to keep global warming at 1.5 degrees Celsius or less, we would need to reach net zero CO2 emissions by 2055. By 2040. We would need to see our peak CO2 emissions occur no later than 2030. We essentially have a decade to get it together. We essentially have a decade to rein in global CO2 emissions. There are a lot of ways to do this. We can do this by instituting government policies, by instituting public policies that aim to rein in CO2 emissions by major polluters, by major corporations. We can make our economies more energy efficient. We can switch from carbon-based energy production to green, renewable energy production. There are all of these things that we can do as a society to make these shifts. There are also things we can do as individuals. There are personal choices we can make to lower our impact on the environment. We can, for example, upgrade light bulbs in our homes. We can hang clothes to dry instead of using the dryer. We can recycle. We can compost. We can eat a plant-based diet. We can switch to an electric car. We can live car-free. But there's one choice that each of us could make that would have a much greater impact on our carbon footprint than any other choice available to us. And that is the choice to have one fewer child. If we choose to have one fewer child than we otherwise would have, we avert all of the carbon emissions that go along with that new human life. And that's a big difference. So that's the intervention we're going to look at today. We're going to think about what it would mean to enact policies that encouraged people to have one fewer child, to have fewer children. And we're also going to focus this question on a particular population, because in the USA, as you see in this chart, carbon emissions are not evenly distributed across populations. The richer countries, the more affluent countries, have much greater average carbon emissions. And within those countries, the top 10% of consumers, the top 10% of earners within those societies, are responsible for an outsized proportion of carbon emissions. This is the result of the sorts of lifestyles that they live. They are more likely to travel than others, and traveling by air especially is carbon intensive. They are more likely to have homes that consume large amounts of energy. They're more likely to spend a long time commuting. They're more likely to drive than to use public transportation. All of these account for a larger carbon footprint for the top 10%. So we want to keep that in mind as we look at these policies. We also want to keep in mind that there are two sets of reasons one might have for limiting the number of children that they have. One set of reasons has to do with a concern for the well-being of your own children. This can manifest in different ways. It might be a selfish concern that you fear the guilt that you will feel if they live difficult lives, or it might be a concern that you have for the sake of the child, that you want what is best for them, and you worry that bringing them into a world where the future is rather precarious is not in their best interest. On the other hand, there are concerns about the well-being of future generations and of the planet itself. You might be especially concerned about those who will be impacted most by climate change, those who live in less affluent countries. Those who are already disadvantaged in a number of ways will likely bear the greater effects. We're going to focus in particular on the second set of reasons, on concern for the well-being of future generations. I'm going to pause here and give you a break because I've been going on for about 20 minutes now. So I'm going to pause and conclude this discussion in a second video.